Hi, I'd like to talk about the greenhouse effect and how it changes the surface temperature of planets that have greenhouse gases. And so, first of all, what is the greenhouse effect? The greenhouse effect is a process. First of all, the sunlight goes through the atmosphere of the planet. Some gets reflected off of the atmosphere. The surface is heated, and the surface, as it warms, ends up emitting black body radiation in the infrared because of its temperature. The infrared light cannot escape the atmosphere. The infrared light works its way through the atmosphere, but then may be absorbed by so-called greenhouse gases such as water, H2O, carbon dioxide, CO2, and methane, CH4. Water, H2O, is the most efficient greenhouse gas in the atmosphere of the Earth because it is relatively common compared to the other gases. So, an incoming solar radiation of 340 watts per meter squared impacts the upper atmosphere of the Earth. 23% is absorbed in the atmosphere. Half of that will radiate back out into space, half of that will radiate back toward Earth. 29% is reflected from the atmosphere. 48%, about half, makes it to the surface, is absorbed by the surface, whether it be the land or the water, heats the surface, and then gets transformed into heat energy and is emitted as thermal radiation in the infrared part of the spectrum. Much longer wavelengths than the incoming light from the sun. And this has a big effect because of the longer wavelengths of the outgoing radiation. Here's a map of the outgoing heat, also in watts per meter squared. You can see throughout much of the lower latitudes, tropical and equatorial regions, a lot of heat is being released from the surface of the Earth. Here is another diagram that shows a few more details. A certain amount is reflected off of clouds. A certain amount is reflected off of the surface. The surface emits a large amount of radiation, and some of that is absorbed by clouds on the way out. Some is emitted by clouds. Some is emitted back towards Earth because of the greenhouse gases. And also there is latent heat due to change of state of evaporation of water into forming clouds. So, and again, the clouds reflect a certain amount of the incoming radiation from the sun. So it is complex energy budget for the Earth, and the molecules that are causing the greenhouse effect are more complicated than the main constituents of our atmosphere on Earth. We have nitrogen and oxygen, which are 71% and about 29% of the atmosphere, have very strong bonds between two identical molecules. This makes them unable to absorb infrared radiation, which other molecules like water here, this is a rotating water molecule, and so it can absorb long wavelengths of light which cause the vibration of the molecule, the different pieces vibrating, and the rotation can occur in several different ways. More complicated structures, even carbon dioxide and methane, are very efficient absorbers of the infrared radiation. So these are the qualities of the molecules that makes them greenhouse gases. Oxygen and nitrogen can absorb some wavelengths, but not as many wavelengths. And so these other molecules act as a barrier to infrared radiation moving through the atmosphere because of how they are efficiently able to absorb that longer wavelength of light. Whereas the shorter wavelength incoming radiation, visible light that we can see, is not affected like the infrared radiation. These molecules do not absorb those wavelengths efficiently. They absorb the outgoing infrared wavelengths. Thereby, they heat the surface of the Earth. Now, if we look at the composition of the atmospheres, not the amount of the atmosphere, this is very different, we'll look at in a second, but the composition, Venus and Mars and the original Earth were all very similar, and Venus has 96% carbon dioxide in its atmosphere, 4% methane, trace amounts of oxygen. Mars, about the same, about 95% of its atmosphere is carbon dioxide. The early Earth was probably very similar. Earth now is very different, and the reason is because biology on the Earth has transformed the Earth's atmosphere. So the oxygen, all of the oxygen in the atmosphere practically on Earth comes from plants, and the fact that we have virtually no carbon dioxide, only trace amounts of carbon dioxide, 0.04% of the atmosphere of Earth is carbon dioxide. All of that has been removed by the processes, especially plants making oxygen and the weathering of rocks on Earth due to rain. If we look at the atmospheres of Mercury, which basically has no atmosphere, Earth, we can think of the units of a bar, which is by definition, the atmosphere on the Earth and on the surface. And so Venus has about 95 times the pressure on its surface as Earth. Mars, a little bit less than 1% the atmosphere of Earth. 0.6% are 6/1000ths of the atmospheric pressure of Earth. So the percentage of carbon dioxide, as I mentioned, is much higher, almost completely carbon dioxide atmospheres on Venus and Mars, with 4% methane. For Earth, only about 0.5% of Earth's atmosphere is carbon dioxide, but it accounts for the majority of, well, the water and carbon dioxide account for greenhouse effect on Earth. So, without the greenhouse effect, the temperatures measured in Kelvin here are 437 degrees on Mercury. It's very close to the sun. Venus, 232 Kelvin. Earth, 255 Kelvin. Again, without the greenhouse effect, effectively no atmosphere. And Mars, lower at 209 Kelvin. Notice that Venus is less than Earth, even though it's closer to the sun. This is because the albedo of Venus is taken into account. Venus reflects much more of its light because of its thick cloud layer, basically 100% covered by clouds that are carbon dioxide clouds in Venus's atmosphere. So one effect is that less radiation comes to the surface of Venus, causing the heating to heat it up. But that effect is overwhelmed by the greenhouse effect, trapping the infrared heat on its way out. The observed temperature of Venus is 735 degrees. This is a raise of 503 degrees over the temperature without the greenhouse effect. On Earth, with the small amount of carbon dioxide and water vapor we have in our atmosphere, 33 degrees, pushing us up to a very nice 288 degree Kelvin temperature, which is basically the common average temperature over the surface of the Earth. 33 degrees warmer than it would be without the greenhouse effect. So without the greenhouse effect, Earth would be a significantly colder, still habitable, but significantly colder environment. Mars, only a small effect, 6 degree Kelvin increase in the temperature, mainly because, not because it doesn't have carbon dioxide, it does have carbon dioxide, but the atmosphere is very thin, and so it's not able to trap that much of the heat that Mars ends up getting from the sun. So, looking just as a summary, the greenhouse effect raises temperatures of Venus, Earth, and Mars to different degrees. There's a carbon cycle which operates on Earth. The carbon cycle is what has removed the greenhouse gases, specifically carbon dioxide, from the atmosphere. The photosynthesis of plants allows them to convert carbon dioxide into oxygen through the catalyst of water. And it produces oxygen, which is not a greenhouse gas, removes carbon dioxide, which is, from the atmosphere. A lot of that will go into the soil, and it will also then eventually go into the fossils and into the crust, which can be subducted into the mantle of Earth. Carbon dioxide can come out of volcanoes and back into the atmosphere. So there's a lot of details with the carbon cycle, but it operates on Earth, removing the carbon dioxide from the atmosphere of Earth, and it's responsible for the low levels that we have now. In fact, without an efficient carbon cycle, keeping the atmospheric CO2 levels very low, the Earth would not be habitable. If carbon dioxide levels were much higher, the Earth would be hundreds of degrees hotter and oceans would boil. This would result in what's called the runaway greenhouse effect, where we result in a state similar to Venus. Not as hot as Venus because we're not as far from the sun, but still too hot to be habitable. On Venus, the greenhouse effect causes the surface of Venus to be hot enough to melt lead on the surface, and all of the spacecraft that landed on Venus, the Venera probes from Russia, were burned up within 1 hour because of the high temperatures due to the greenhouse effect. So that's the greenhouse effect on the planets Venus, Earth, and Mars.